Hi, in this video, we're going to talk about, well, a few topics that are all related: order of execution, simple table, and scope or namespace. So first, let's look at a very simple program. So here I define an x, and then I define a function called printx, which just print x literally, and then finally I call printx. So if I run this, you would expect that it prints out x. So no surprise there, hopefully. All right, so what if I do a little bit of changes? Instead of putting in x in front of print x, I put it after. Okay, so take a moment to think about this. Does this still work? Well, let's run it, and it does. It still prints out 10. So you might question that, okay, well, I mean, the function here, it seems to reference an x that has not been defined yet up to this point, right? Because x is defined after the definition of print x. So how possibly could that work? Well, let's take a look at why it works. All right, so remember a few things. Let's see. Well, here. Um, so a few of these things you're expected to know by this point. That first, Python is an interpreted language, right? So it's not compiled, which is different from C++ or Java. The second thing is true for most programming language, that the code is executed from top to bottom, okay, right here from top to bottom, except when there's control statements such as conditional loops and function calls, etc., etc. Third thing, the function definitions, and by that I mean, when we're defining a function definitions, they are not executed. Okay, so the functions are executed only when they're actually called. So the function, this is when we actually call the function printx. So that's when we actually execute the code inside that function. And so the last item, which may be new to some of you, is that the variables or functions or classes, when they're defined, they are added to this thing called a symbol table. Okay, and let's see what symbol table is. So what a function table is, it basically contains key value pairs that maps the name to definitions. So by name, I mean, for example, this is a variable, the name is x, and the definition for x, or rather in this case, the value for x is 10. So the symbol table maps the name x to the value 10. Now, in Python, remember, everything is an object, right? An integer is an object, a function is an object, even a class definition is an object. So more accurately, it really maps the name to the actual object that represents the function, the variable, the class, etc., etc. So a quick question. Um, a data structure that contains key value pairs, what is that in Python? Yeah, this is something that you use quite a bit, hopefully, in your past projects. Well, a dictionary, right? The dictionary maps a key to a value. So just want to point that out. All right, so let's see the symbol table in action given the code that we just wrote. So here's a symbol table. Basically contains two columns. One is a name, the other is definition, or it's actually a reference to the actual object, as we'll see. So before we execute anything at all, the symbol table is empty, right? So now once we encounter a definition for a function, what's added to the symbol table is the name of the function. It's printx, and the definition. Now the symbol table itself, in reality, it does not store the definition itself. Rather, it kind of stores a pointer to the actual function object that represents the function printx. Okay, so we don't really need to care about what's inside the function object, as long as we know that the name is reference to an object that has been created, a function object that has been created. Okay, so and that's what happens with the function definition. It doesn't actually execute any code inside the function. It only adds the function definition there, or the function object to the simple table. All right, and we go to the next line, which is x equal to 10. Sure, I would expect it adds the name x, and it maps x to an integer object that contains the value 10. Okay, and the next line, now we call the function printx. Now, when Python sees the name printx, well, it needs to know what that is. So it actually looks it up in the simple table, and then it says, okay, well, printx is a function object. Okay, and it wants to call the function. So, okay, let's execute the function, right? Which is right here. So it steps into the function, and then it sees that, okay, well, it wants to print x. And now it encounter another name, right? X. What is x? Well, it looks up the simple table again, and then it sees, okay, x is actually an integer object that contains the value 10. So it's able to print that out on the screen, and then that's why it's able to work, even though x, at least the way the code looks, seems to have been defined after the definition of the function. Okay, so the next question is here. In this example, I just showed just a single simple table. Well, is there just a single simple table in Python? Well, not quite. So the one that we see in this example is what's called a global simple table. Okay, so it contains all the name that is defined in the global scope namespace. Okay, now there is also a local simple table. And what it is it's a simple table that is local to a particular function that is currently being executed. And it contains all the names that are defined in the local scope that are local to the function. So let's see how that works. So let's keep the same function definition. We just add one line, well, actually 2 lines to what we have. So we define a y, a variable in the function printx. We set it to 20, and after calling printx, we try to print a y. Would that work? You should know whether it works or not. So let me actually do that here. So if I say y equal to 20, and if I want to print out y here, and when we run it, it's not happy. Actually complains y is not defined. Why is that? And so let's look at it again, see how it works in case of the from the perspective of a simple table. Okay, so we've already kind of we execute through everything, and we come to this point. We are calling printx. So we already have printx in the simple table as well as x itself, right? So when we go inside printx, it prints up. What happens is that, oh, I forgot to mention here, right? All these definitions there in the global scope. Now, when we step inside printx, a local simple table is created for the printx. Okay. And so what actually really happens is when it encounters the name called x, the first simple table that it looks at is the local simple table. Well, the local simple table is empty because we just enter printx, there's nothing. So it couldn't find it, but because it's just a local simple table, the next thing that it will do is it will then go up to the global simple table and see if there's an x there. Okay, there is, and it's able to find x and the value of x, which is 10. So it's able to print that out. Right? As you can see, it was able to print out the number 10 here. Now, and then when it comes to the next line, we created a variable called y and assigned 20. So because it's a local variable, so we put that symbol inside the symbol table for print x. So y maps to an int object that has the value 20. Now, at this point, we are done with print x, the function. So we return from the function. And what happens when we return from the function? Well, because this symbol table is local to print x and we're done with print x, so that symbol table is actually gone. So there's no longer this local symbol table for print x, and y is gone with it. So when we're trying to print out y, it couldn't find anything, right? There's no more y. So that's why we see this name error that y is not defined. So just kind of to recap, basically every definition of everything, variable, function, classes, is associated with a name, basically in the symbol table. Okay, so there's the global symbol table, which kind of just it lives across the entire execution of the script, right? And then there's the local symbol table, which is local to a function. They are created when the execution enters into a function, when a function is called. And these local symbol table, they are removed when that function call is finished. And there are other kind of scope, such as enclosing scope, but well, let's not worry about that right now. And the name definition pairs, they are added to kind of either the global symbol table if the code being executed is in the global scope, or they are added to the function's local symbol table if the name definitions they are encountered inside a function call. Okay, and then when the interpreter sees a name, it will then search the symbol table in a particular order to see if that name is actually associated with some particular object. Right. So for now, the order is basically it starts looking into the local symbol table first if it's inside the function, and if it's not there, then it goes up to the global scope. And if you want to understand the fuller picture of how this thing works, I have a link here that you can read. And so this is basically the simple lookup. That's basically how a function can access or read a global variable, even though that variable is defined in the global scope rather than the local scope. Anyway, now if you want to modify a global variable, that's actually a little complicated if you have done that before, and usually that's not recommended. But again, if you want to understand how it works, here's another link to explain how that works. So now that you understand how the symbol table works, here are a few code fragments for you to look through. So what I suggest you do is look, kind of think through the execution of the code and see if it will run without error. And once you have an answer, then you can type out code in the Python IDE, run it, and verify that it hopefully matches what you think. And if it does not, then try to understand why not. So here's the first one. And then here is the next one. And then here's the next one. And then here's one more.